So thank you everyone for coming here to this panel. And we would like to begin with the power break that we had at the beginning of June. We witnessed an initiated power break carried out by the electric company. That power break brought down the electricity above many houses in Israel. We all experienced that. Entrepreneurs working in the field of renewable energy that could have prevented the last power break and those that will come after it, today encounter burdensome regulation and government policy that do not sufficiently encourage Israel's transition to green energy. But not just in Israel. Globally, there is difficulty meeting in climate goals set every year at the climate conferences or published by the European Union or other entities. So I would like to start with you, Dr. Bracha Halaf. You have seen the field of energy from many angles as the chief scientist of the Ministry of Energy and as an investor. How do you think that we can overcome the challenges in terms of policy and regulation, especially since we are talking about the maritime, where on one hand, the potential is endless, but on the other hand, what happened to my microphone? Okay. But on the other hand, there are a lot of regulatory difficulties.
Hi. Thank you for inviting me to this very honorable panel and for this super interesting conference. And I must say that I thought that I will spend more time outside, but the program here was so fascinating that I spent most of the time here. So first I'll introduce myself. I'm currently the co-founder of Gravity Climate, which is an early stage VC based here in Israel and focused on climate technologies in all aspects of climate with some emphasis on more on the energy side, chemical sides, and things in and around that. And as Hila mentioned, I was the chief scientist in the Ministry of Energy. I was 9 years I spent over there after graduating my PhD studies. So I always worked in the interface of science, technology, and regulation. And this is something that is super crucial for the innovation ecosystem in this space. Because you cannot make innovation, you cannot implement innovative technologies without the support of the regulators from the very inception of those technologies. So in the ministry, of course, we dealt with energy, water, natural resources. A lot of emphasis was put into, as was mentioned before, to the natural gas development of the natural gas reservoirs in the Mediterranean Sea and all the assessments of the environmental impacts of that, and also on aspects of renewable energies and technologies for more energy efficient technologies and such, and in new fuels and more environmental technologies. And in all of those activities that I've pursued in my role, it was much more than granting R&D projects, which was in academia, startups, and pilot and demonstration. The main role that I had at the time and our ministry took on itself is to support those innovations throughout their research phase and to create the regulatory framework that will allow their implementation. And in such things such as the blue economy, this intersectoral considerations are very influencing the development of these technologies, as I said, from the very beginning. So we supported those technologies. We sometimes had some intergovernmental and cross ministries committees that worked alongside with these technology developers and escorted them and provided them the guidelines for how to measure, how to conduct their pilots and research. All of such was part of our intention to create the guidelines for the policy that will then enable entrepreneurs and researchers to implement what they are working on. And I think in climate and in maritime technologies and blue economy, these entrepreneurs and researchers really have to, swim against this ripe current of obstacles and difficulties. It's not only the technical and regulatory obstacles that they have. It's going through a lot of capital and equity requirements that they have along the way, and all the way towards public perception, which is for itself something that you'll need to encounter and work with the public from the very beginning of such projects.
Thank you very much, Bracha. So I would like to ask you another question, but what are you looking for as an investor? Because you are today investors in energy-related innovation.
So at Gravity Climate, we seek to diversify our portfolio and our investments with intersectoral and modes of technology, so both hardware and software. And this is something that, the current timing is very appropriate because we see that we are at a tipping point where disciplines interconnect to create added value. So for instance, optimizing and management of grids and of facilities that are both for production and consumption of energy is something at our scope. Things that has to do with AI and machine learning and computer vision combined with physical sensors for the monitoring of emissions in different environments. I think also very on our mind is the area, the whole era of green chemistry and green and some new novel materials and chemical processes that are required for a more efficient energy production and storage, for even in the industrial part of mining and green chemistry. Those are things that we look at and we think there's a lot of potential there.
Thank you very much. So now I'm moving to you, Ina. Let's look now at the solutions. In face of there are many challenges, such as the climate crisis, the energy crisis, and all of others. Innovation is coming up with very good and important technological solutions. So, Ina, where are we today with generating renewable, sustainable energy from the ocean, and how far are we from where we need to be and can be?
So today I think we're much more advanced and we're going towards the goal of really starting to commercialize wave energy. It's still not at the point where solar and wind is, which started its commercialization efforts much, much before. But for example, Israel for the first time in history now signed a PPA with the EcoWave Power, a wave energy developer, which is actually with the help of Bracha and Amir here. Bracha was the chief scientist that recognized us as pioneering technology and also gave us the partial funding for our new Jaffa port installation, which will start selling electricity in 1 month. So it took time, but happened. And Amir worked in EDF, Renewables IL, and they're also our partners in the project. So we're very excited. I believe that, we're taking right now the steps to bring the commercialization of wave energy forward. So we're starting with pilots. One of them is here in Israel. It's the first time that houses next to Jaffa port can maybe open their washing machines and TV with the power of the waves, which can be super cool and interesting. After that, of course, after the pilot stages, we want to move to commercial scale. And because of the Jaffa project, we also signed an agreement with the Port of LA. So we're putting now a pilot also of 100 kilowatt in the Port of LA. With the aspiration to build there up to 60 megawatt, because they have a very, very big breakwater. We also signed a commercial agreement in Portugal for 20 megawatts and some other locations based on the visits that they show in the Jaffa facility. So I think wave energy has a great potential. According to the World Energy Council, it can actually produce twice the amount of electricity that the world produces now. So that's definitely something that we need, especially like you said, with the energy crisis and climate crisis that is happening. We're starting small, and the small will grow into big, exactly like happened with solar and wind. And the more support we have from policymakers, regulators, legislators, we can make it happen faster.
So this is very exciting. Thank you. And I would like to ask you about sea wave energy is one of the mature technologies in the field of renewable energy, and we still do not see companies overcoming the barriers and the challenges in front of the enormous potential that the field has. How do you solve it?
So I think in the past, wave energy didn't commercialize because most of the solutions were pretty complicated. They were building wave energy solutions offshore, 4 or 5 kilometers into the sea. And when you put something that far into the sea, it becomes very expensive. You need ships, you need divers, underwater mooring, cables. Also in the offshore, you have waves of 20 meters, even higher, and no stationary man-made equipment would survive the loads of a 20-meter wave height. So it was expensive, it was breaking down. Environmentalists weren't sure if they like it because a new presence on the ocean floor may disturb the marine environment. So EcoWave Power basically did it differently. We connect to breakwaters, piers, jetties, and other types of existent man-made structures. And basically by doing so, the price goes down, the reliability goes up, there's no environmental impact because we don't connect to the ocean floor. Now, kind of the problem for us, I think that we encountered in growing bigger and faster is that in many countries there is lack of legislation. So many times I'm speaking in events like this, and after a port or a government official comes and says, wow, we have this amazing port, come install it here. And I get all excited. I say, okay, when? And then they say, we don't know which licenses are needed. We don't know how do you connect to the grid. So basically, the technology readiness level right now is higher than the policy readiness level. And that's a gap that should be closed. And a second barrier, I would say, is the lack of debt financing for wave energy. Because it's a very, very new type of renewable energy, most of the funding of our project we do with strategic partners like EDF, grants like the Energy Ministry of Israel, or with equity. We're a publicly traded company, so we can also fund projects with equity. But of course, the fastest way to reach commercial rollout and build many, many projects in parallel is debt financing. So that's the two problems, and I do believe, as an entrepreneur, I have to be optimistic. So I do believe it will be solved because wind and solar had the same problems when they were starting, and now they're fully commercialized. Thank you.
This is very interesting. I do hope that this problem is also being solved. So now I would like to ask you, Mr. Yonadav Buber. We talk about the importance of accelerating the renewable energy transition. All this ambition cannot be realized without the transmission infrastructure solution of the missing part of a reliable, large-scale energy storage solution. Where do you come into the picture?
Sure. So first of all, thank you very much for having me. And yeah, and right now, it's interesting. I think from around 2015, people understood that renewable is fantastic, but they create a certain problem about grid management because suddenly you cannot turn on or turn off power, and you can't really match, the power producer with the power consumption. And they understood that they have to have some kind of a buffer, and this is where long duration energy storage in large scale, such as what Baromar is developing, comes into play. And it basically enables all the grid operators on a national scale to really utilize 100% of the renewable energy, which is currently impossible to do. I mean, you see it right now in Europe, you see it around the United States, you even see it sometimes in Israel, where energy is produced by renewable sources and has to be discharged because there is no one in the grid that can actually take it. And this is a major hurdle in order to make, to go the extra mile and to go 100% into renewable. Because at the end of the day, prices dropped for renewable. It really is possible. I mean, we're talking about such an evolution of this market. And what Baromar is trying to do is basically use a very proven technology, which is called compressed air energy storage, which is CAES. And we're basically solving the problem with this technology. which is the geographical location of holding this compressed air. So what we're doing is that, and this is not my idea, you know, it's an idea of my partners, which are, I say that they're the best kind of geniuses, because the best kind of geniuses for an idea is it has to be so simple that even someone with no experience can understand it and can understand the implication. Is just fantastic. So what we're doing is that we're simply storing the air underwater, very simple concrete structures, and using the pressure of the ocean to keep the pressure of the air. And by that, you know, we're just basically bypassing the need for a geological structure, such as a depleted gas reservoir to hold the air. And we can do it just about anywhere that we have access to the ocean. And we're really fitting into this fantastic convention because this is blue economy at its best. You know, you're taking the assets of the ocean, which are currently unutilized, and you're utilizing it in order to really benefit the current system without harming the environment or without any other such, you know, nasty implications.
I understand. This is very interesting. Thank you. So I would like to know, what is your competitive advantage compared to other companies that operate in your field?
So, first of all, there are not that many companies which are operating in long duration energy storage. There are batteries, but batteries are not long duration by any chance. And they're unable to take the capacities that we're talking about, which is gigawatts and gigawatts of energy. But I think that the best way to really understand this is use the Occam-Razors test. The Occam-Razor test basically says, you know, if you have a complicated solution and you have a simple solution is always the best one. So we have a very simple solution. It's a proven technology. It's available today. It's extremely scalable. You can use it just about, well, we recognize a lot of different places in the world where we can utilize it. And it's very environmental friendly. We have almost as close to a zero footprint as we can. And the best part of all, it's extremely, extremely economical, which means that we can really help countries on a country level reduce the electricity prices to the final consumer, which is just fantastic.
This is very interesting. I wish you the best success on succeeding that, because it sounds very important. Okay. So our next speaker developed a creative and smart solution that an equally acute problem, such as reducing carbon emission, which is very, very important. So Mr. Amar, what does Rewind.earth do? This is your company.
Well, I like what you said about simple solutions. I'll come back to that in a minute. Let me rephrase the problem, because it's not reducing emissions, it's cleaning emissions from the air. We started this session with saying that the hunger of humanity for energy is not going anywhere. Depressing thought as it is, but even if we did produce all of our energy with renewable sources tomorrow morning, we still emitted more than 1,000 billion tons of CO2 to the atmosphere, and we need to clean it. At least somewhere in the order of 300 billion tons. So the largest industries of humanity, oil, agriculture, produce a yearly product of about 10 billion tons per year. We need to clean 300 billion tons of CO2 from the air. That's an incredible challenge. An industry that doesn't exist that need to get up to those same levels. So being Israeli with a background in cybersecurity and startups, we thought, well, how do we hack this problem? How do we get to the largest amount as fast as possible? And that led us to rely on nature. Nature is the best CO2 capturing machine with what we see here on the right side of the hall. Plants, they capture CO2 great, but we didn't want to go and plant trees because it's hard and takes a long time. And 2 trees, they only hold the carbon for maybe 100 years. And that's not enough when we're talking about carbon that has been underground for millions of years. It's not enough just to capture it for 100. So then we said, let's not grow trees, let's collect residual trees, because there's plenty of agriculture, plenty of forestry in the world that produce maybe about 20 billion tons of residue every year. But where are we going to put all that residue? If we just create a pile here in this room, in 100 years' time, it's going to disappear. Microorganisms and fungi will decompose it and break it down back to CO2. And that was the second hack. You know, the first hack, take residual trees. Second hack, let's find places in seas where there's no oxygen and they're big enough to hold and preserve organic carbon for thousands of years. And this is how we came to the Black Sea. So our solution became very simple. Let's collect residues from agriculture and forestry, ship it to the bottom of the Black Sea. It's 2 kilometers deep. There's no oxygen. It's very sulfidic. Almost nothing lives down there. And whatever carbon we put in there will stay there for thousands of years.
So it's very, very interesting and very important. Yeah. So how do you face the challenges of creating a reliable and efficient carbon crediting and trading mechanism that supports your solution?
So comparing to trees again, anybody can go plant trees. And about 12 years ago, we started this mechanism called carbon credits. And we said, okay, anybody who plants trees will pay you about a few dollars per ton for that tree that you put in the ground. And what happened is that many people planted trees, got the money, 10 years later, cut down the trees, sold it to IKEA. As a very unsustainable mechanism, and it's being replaced by a new carbon crediting mechanism, sometimes now called carbon removal crediting. And it requires proof of permanence. So you plant a tree, you have to prove it's going to be there for 1,000 years. It requires accurate measurement. So if you plant a tree, how much carbon did that tree take up? It's not enough just to say, about 10 tons. You have to be very accurate when you charge $100 per ton for that tree. And all of that is technology that we're building. Starting from where we got the biomass, where we got the organic carbon, and make sure it's sustainable so nobody cut down huge amounts of forest to provide us with biomass. Then you have to understand how much carbon is in the tree. An oak tree and those leaves here and those bushes have a different percentage of carbon in them. And ultimately, once the carbon is on the bottom of the Black Sea, you have to continuously monitor it to make sure it doesn't disappear, it's correctly quantified, it doesn't create any undesired environmental effects. All of these are part of our MRV system, measurement, reporting, verification, and it's absolutely required to get paid for removing carbon.
Great. So thank you very much. And I would like to ask you, Amir Horowitz, about ESIL, which is a new initiative. It looks like a very interesting initiative. So we would like to know, what does ESIL do? Who founded it and why?
So thank you for having me. ESIL was founded by 3 different companies from 3 different countries and 3 different industries. EDF Renewables, French-based renewable energy giant. It has the largest portfolio of renewable energy in Israel, and the mother company, EDF Group, is one of the world's largest producers of electricity. Bazan, which is Israel's largest petrochemicals conglomerate, and Johnson Matthey, which is a UK-based chemical process giant. The why is interesting. I think many similar motivations between the 3 companies, but not identical. As Ina mentioned, in my previous role, I headed the innovation activities for EDF Renewables in Israel. And EDF was already heavily involved in cooperations with startups in Israel, but mainly with more mature startups in JVs, in joint projects, POCs, etc. But what we identified, that there was this huge plethora of early stage startups that we couldn't engage with. They were not mature enough to really form a partnership with and to test their products. And we didn't want to wait long enough for them to mature, obviously for fear of missing an opportunity. So on EDF's part, the main motivation was tapping into that big pot of early stage startups and forming collaborations with them at a later stage. Bazan, on the other hand, had already made some investments, but also with later stage startups. And they also were trying to form, to gain access to this area of early stage climate tech startups as part of their long-term decarbonization philosophy. Johnson Matthey is the odd company out. They did not have a fixed representation here in Israel. And I guess they heard the Startup Nation pitch more than one time and were convinced and really wanted to gain access into the Israeli market. For them, the decarbonization of chemicals as an end product and the processes of producing chemicals, that's their flagship in these recent years. So for them, this was their access into the Israeli market. So these three companies were not identical in what they do, which meant they were not competitors, but they were close enough in the way that you could form a cohesive partnership and they could work together. Another point I would make on that is we received generous support from the Israel Innovation Authority. And looking from the outside in, you would think, why do these companies need to be supported by the state? Each one of them on its own could have formed and could have run this operation in itself. They have enough resources to do it. Fact is, none of them did, and most companies, most multinationals don't run this type of activity. The minute that the opportunity was on the table to form a partnership between the three companies to receive the support of the Innovation Authority, I think it's a great example of a private-public partnership that has results. And today, looking back after about 2 years of operation, you can see that this has actually created some real value.
This is very interesting. And I would like to know what is your investment philosophy when it comes to renewable energy project and innovation. And another thing I would like to ask, do you work with academia?
Okay, so I would say that as I represent strategic rather than financial investors, there's a disproportional emphasis on technology. Now, obviously, nobody would invest in a company without a stable technology to lead the company forward. But my shareholders are willing to suffer, quote unquote, a longer time to market, higher risk, if they believe in the technology's potential. Usually the stage where we meet the companies, they're far away from a commercial product, but they have the potential. We run a due diligence process. We believe in the potential. So technology is king as far as I'm concerned. Obviously, after technology, you would look at potential market segment and leadership team and all the other fields that you would look at as in any other investment. But again, definitely the emphasis is on technology. And I think I would put another spotlight on startups that can find common ground with one of our founding partners in what they do. Now, you would think that that would limit the areas of focus in which we deal. But if you look back after only about, as I said, about 2 years of investments, we have companies dealing in everything from carbon capture to hydrogen storage to autonomous robotics to weather prediction to solar paint to contaminant identification, et cetera, et cetera, et cetera. I can go on into more investments that we've made. So these three founding partners and other partners which we intend to bring in the future enable us to really look at a really wide area as far as investment areas, and I think give the startups a real added value, a real benefit, apart from the financial investment, which has to be part of the deal.
Thank you very much, and we almost run out of time, but I do want to ask you, all of you, what do you think are the next big trends in blue economy and energy innovation and investment? But please be short because we don't left enough time. Thank you.
So in the blue economy, I think that we should put a lot of emphasis and a lot of money into the monitoring, reporting, and verification tech, because this will be the enablers of all activities in this space. So as I said before, those technologies need a lot of regulation in order to start even their pilots and their field tests. Regulation cannot be built without data, and this data will come from these technologies. So,
thank you.
As far as I see a lot of untapped potential in wind energy, in offshore wind, mostly in deep water, where today it's inaccessible, but there are developments in floating offshore wind. Onshore in areas of low wind areas or urban areas, so the entire vertical of micro turbines, which we've seen several developments which have not become commercial yet. Onshore wave, as was mentioned, and of course hydrogen, the buzzword of the year, or maybe several years, both as a means of a means of energy for shipping, or as a means of energy storage from getting energy produced offshore onto the shore.
One huge area is decarbonizing shipping, of course. Anywhere from point source capture on ships and offloading the CO2 at ports to electric ships that have to recharge at ports with underwater compressed energy. And also carbon removal using the ocean. Again, looking at the planet, the ocean is the largest absorber of carbon on Earth. And lots of techniques, not just sinking terrestrial biomass, but also growing seaweed and letting that sink, macro seaweed, also micro seaweed, algae, as well as ocean alkalinization, scattering limestone in the sea. So those are two huge areas of innovation.
I think that well, it's a real blue ocean out there, right? I mean, you have so many interesting ideas that some of them were, discussed here, and there's so much to do, and it truly is, by the way, an uncharted land, right? I mean, they always say that we know more about the landscape of Mars than we know about the landscape of our oceans, and we have here in Israel and all over the world so many different ideas about how to really utilize the blue economy, and basically, I think that the next decade is going to be very interesting, especially in the energy field.
Excellent.
So, of course, I agree with everything that has been said. I see that the blue economy has significant potential. Being from the wave energy sector, I see a lot of progress. Just 2 days ago, the California Senate approved for the first time in the history of the United States official legislation giving $1 billion to wave energy. Based on the project that we're doing in LA, we helped draft the legislation, and I gave the testimony before the legislative committee and the Senate there. So we see a lot of regulatory progress, we see a lot of programs in terms of investment, in terms of implementation, and I think the best thing about wave energy is the fact that it's not coming to replace any of the other sources, but it will be a great add-on to solar and wind energy, because like renewable energy, in the end of the day, it's renewable. It's fluctuating. Solar is an amazing source, but at night, it's dark and you can't produce. And wave energy can produce in suitable locations around the clock. So combining all renewable energy sources together is really what will bring us a 100% environmentally friendly world.
Excellent. So that is very interesting. Thank you all of you for coming here. And I'm sure that I'm talking with all the audience, everyone here in the hall, that we are just looking forward to see a growing blue economy ecosystem here in Israel. And thank you for coming. Thank you.
Thank you.